For period 3B, I actually went through all your homework assignments and started tallying how many, or the specific questions that were being missed. A couple of you asked about question 4, a couple asked about question 9, but it was definitely not the majority. At some point, I stopped counting for your class because more than 10 students had numbers 3, 5, and 7 circled. So those are obviously the questions that I want to go over. And if you have other questions, you can wait till the end of conference and I'll go over that with you individually. I also want to mention there are many different ways that you can solve questions on probability. And what I've realized is that a lot of you are a little more intuitive when it comes to like finding the likelihood of some kind of event occurring. And you do it a different way than I do, which is completely fine. So if you don't like how I am doing it, just continue doing it in a way that logically makes the most sense to you. So in the examples that I do right now, again, you might have done it a different way, and that is completely okay. So for question 3, you had 4 female and 4 male kittens together in a row. And because it says that we have an arrangement, most of you probably determined that you're going to have some kind of permutation where the order in which you arrange your kittens matter. So what I would have done is I almost always do some kind of like visual representation for myself. I have a total of 8 kittens, and the denominator, when you're finding the probability of some event, it's always equal to the number of ways that event can happen over the total number in my sample space. Well, my sample space in this case would be how many different ways can I arrange just all 8 kittens that I have. So that would be a permutation since the order does matter. And it would be a permutation of 8, 8. I want to know how many different ways can I arrange all 8 kittens. You also could write it as, of course, 8P8 as well. That represents the same thing. I don't really care about your notation. And some of you, for combinations, like, I don't know, 8C4, you could also write it like 8, 4 like this too. Again, many different notations, they all represent the same thing, and it's fine. So my numerator then would be how many different ways can I get this event to happen? So the event specifically is that all the female kittens are together and all the male kittens are together. That's my event. Well, that could happen if I have female kitten 1, kitten 2, kitten 3, kitten 4, and then I have male 1, male 2, male 3, male 4. And of course, you can expect that this is going to happen in a ton of different ways. I could switch female 2 and female 1 and then keep everything else the same, etc. And instead of listing out all the possible ways this event can happen, I want to find some kind of shortcut to do that. And because I have the 4 female kittens that I'm just rearranging to find all the different possible arrangements, this would be a permutation of 4, 4. Of my 4 female kittens, how many ways can I arrange all 4 of them? And so there's 24 different ways that I could have an arrangement of all 4 of those female kittens. Then I also want to know how many different ways can I arrange all the male kittens? Well, I could have female 1, female 2, female 3, female 4, and male 2, male 3, male 1, male 4, etc. And then I could have this with another arrangement, this with another arrangement. So this would be also the permutation of 4, 4. How many different ways can I arrange all 4 of those male kittens? I'm going to multiply those together, and I end up getting 24 times 24. But the reason why this is not my final answer is because I assumed that the 4 female kittens come first and then my 4 male kittens. However, they could also be in reverse, where I have all the male kittens and then all the female kittens. So that's why you would have to take this and also multiply it by 2. Just to take into account the males and the females switching spots. So then when you do this, you end up getting 1,152 divided by 40,320. Several of you asked questions in your homework assignment. Can you just leave it as a fraction? Yeah, I really don't care if you reduce it or not, or you leave it as a percentage or a decimal. All the different variations of your probability are fine as long as your answer is somewhere between 0 and 1. Please make sure you don't have a probability greater than 1. And then this you also could have reduced to 1 out of 35. Just keep in mind that if you are given a question on a test and it is a multiple choice question, if you end up getting this answer, and you don't see it somewhere on the multiple choice, just reduce it and see if it happens to match what you see in the answer key. I'm going to try my best to make it so that like no matter what you type in, it's going to be marked correct. Do you need to put the probability of an event thing, or can you just write the fraction? Oh, you can definitely just start your work right here. And again, this is one way you could have done it. And when I checked your homework, a lot of you did it in a different way and it worked as well. So yeah, this is just a reminder of the lesson that you watched. No, you can just put the fraction, yeah. If you leave this as your final answer, that's completely fine. And in terms of work, again, I don't care how you do it because some people will just list it out in their head and like come up with the answer too, which you'll see in future examples as well. So continuing on to number 5, 5 and 7 are very similar. So once we do one example, my hope is that you understand the other. An election ballot asks voters to select 3 city commissioners from a group of 6 candidates. So I have 1, 2, 3, 4, 5, 6 candidates, and I am selecting 3 city commissioners. What is the probability that both will become city commissioners? So again, when you're coming up with like the probability, the denominator is going to be how many different ways can you just create a group of 3 city commissioners. So it doesn't matter what order in which these people are selected. It would simply just be a combination of the 6 people. How many different ways can you select 3 of them? And again, I know some of you have learned combinations and permutations already. I can tell from looking at your homework assignment, and you can write it like this too. So just putting that out there because there were quite a few people in this class that did that. So this is how many different ways I can just select any random 3 people from a group of 6 candidates. My numerator specifically, though, is how many different ways can my aunt and my father both become the city commissioner? So this is one of those types of examples where you don't necessarily need to do a combination or figure it out using some kind of formula. You can simply fix your aunt and your father in that spot. How many different ways can those 2 people be chosen? Well, if I fix them here, then they have to be chosen. There's only one way that can happen. And there are 1, 2, 3, 4 people that are left on this ballot. Well, it could be my aunt and father in person 1, or it could be aunt father with person 2, or aunt father with person 3, or aunt father with person 4. There are 4 different ways out of the total, I think it was 20, that you can end up getting just your aunt and your father being part of this 3 city commissioner group. I guess mathematically, if you guys wanted to do some kind of combination, you would have seen it as like your aunt and your father being here. That would be the combination of 2, 2. You have to select both of them. It's just one way that can happen, times the combination of the 4 remaining people. How many ways can you select to one of them? You would still end up with 1 times 4, which is equal to 4. And my final answer, I think, is 4/20 is a probability or like a 20% likelihood. Moving on to number 7, since I don't really see any questions coming in. There are 4 people in your family. Your family are 4 of the 12 standbys who hope to get on a flight to Hawaii. Again, this is very, very similar to the previous question, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 6 seats available on the plane. So these are the 6 people that are going to be chosen. The denominator, the total number in my sample, how many different ways can I select 12 or can I select 6 different people for this flight out of the 12 people that there are total. So that would just be a combination of 12, 6. For my numerator, that would be how many different ways can my entire family be selected for this flight? So it could be you, your sister, your brother, and your mom or something. So these are the 4 people in your family, and you want all 4 of them to be selected. Again, for the remaining 2 people, it could be any one of the random 8 that you still have remaining. So it could be the 4 of you plus person 1 and person 2, the 4 of you plus person 4 and person 8, the 4 of you plus, you can't do 8 and 4 because that would be the same outcome as this one. Again, the order doesn't matter in this case. So it would be like person 8 and person 3, etc. If you wanted to, you can literally list out every single possible outcome, but we know that we can just do a combination to make that a little bit quicker for us. There are 2 remaining spots. And how many different ways can we select the 8 people to fill those 2 spots? That would be the combination of 8, 2. You, sister, brother, mom is just like 1 times the combination of 8, 2. So it's a combination of 2, 2, 8, 2, and then you would end up getting your final answer. Oh, sorry. I don't know why I did 2, 2. 4, 4 for the 4 people here. Right. I think that was something like 28,924. Again, I'm not going to reduce that, but you guys can reduce it. I don't really see any other homework questions coming in, so hopefully that did clarify it a bit for you if these are questions that you had. With that said, we are going to complete the class notes from last time. So hopefully this only takes like 10-15 minutes. Number 8. This entire section in the video notes were left blank, letters B, C, and D. So what I would like you to do is answer as a poll question, letter B. What is the probability that if you choose a single M&M from the bag without looking, you choose a yellow M&M? So go ahead and look at all the responses. If you need 30 seconds to take out your classwork, go ahead and do that. But you should see a poll appear. Please respond to that, and that's how I'll be taking attendance for today. I'll wait another minute for the rest of you to respond. Okay, the correct answer was B. I think some people chose D, not reducing it, or just not reading the question carefully. You have a total of 55 M&Ms in your bag. 11 out of them are yellow. So 11 out of 55 reduces to 1/5. Again, like I mentioned earlier when we went over the homework, no, you do not have to simplify them. But if you're given a poll question, yes, you do have to know that 11 out of 55 is equivalent to 1/5. That's okay. Yeah, Catherine too. Okay, yeah, you guys were the 2 that didn't respond, so thank you for letting me know in the chat that you're there. Letter C. What is the probability that if you choose 4 M&Ms at a time, you will choose 4 yellow M&Ms? So I'm going to put a poll out again. Go ahead and respond when you're ready. About 15 more seconds for the rest of you. Great. Thank you guys for the results. Yes, the answer was letter B. Question 8D. I reduced it. What is the probability that if you choose 11 M&Ms at a time, you will choose 11 red M&Ms? I think you guys all get the point if you were able to do letter C correctly. So I put the answer up for letter D if you wanted to check that against your class notes. This is the combination of the 12 red marbles that we have. How many different ways can I select 11 of them? And the denominator, the combination of 55 total M&Ms, how many different ways can I select 11? The number is so small. We never really say the probability is exactly equal to 0 or exactly equal to 1. There's a chance of anything in this world happening. So the probability is so close to 0, but again, it's not exactly equal to 0. To answer your questions, again, this type of question, I would make a multiple choice question. And you would see either this result or you would see this result. Or if I asked you, like, how do you set this up? You would see something like this as a particular answer choice. So no, you don't have to round this. Do you think someone actually does this first try somewhere? Like, do you think someone actually does this? Like puts 55 M&Ms in a bag and selects one? Maybe. I mean, there are so many things, exactly, like Evelyn said. The chances of people doing this could happen. I don't know. For questions 11 and 12, I think these were the only other questions that were unanswered in your video notes, so I did want to go over that as well. In number 11, you being selected captain, of course, of the 15 players, there's just one of you, so 1 out of 15. Oh yeah, sorry. I think there's actually 2 more after this. I forgot. Thank you, Erin. And the poll question that I'm going to ask for number 11 is, what is the probability that you and your best friend are going to be co-captains? So again, look over the answer choices, and when you're ready, please respond to the poll. I think I'm waiting for one more response. Thank you. Okay, the correct answer was letter A, 1 out of 105. Sorry, I'm going to go back one more time just for the 5 of you that need to see the correct answer. And again, for any of these that you're getting wrong, it could be that you didn't simplify it correctly or whatever it may be. If you are unable to figure it out after, then let me know and I'll walk through it with you individually. So number 12 and number 16, sorry, these are the last 2 that we skipped over. Number 12, drawing 4 cards out of a standard deck, what is the probability that you will choose all 4 aces? This is similar to, I think, question 9 in your homework assignment. Drawing 4 cards out of a standard 52 card deck, the denominator is 52-4. The combination of 52-4. Of the 52 cards in your deck of cards, how many ways can you just select any 4 of them? The probability you choose all 4 aces, in a deck of cards, there only are 4 aces. So for you to pick all 4 aces, the event is only going to happen in one specific way. It's either you pick all 4 of them or you don't. Again, this could also be just the combination of the 4 aces you have. How many ways can you select 4 of them? But I want us to move into just thinking about each of these events logically. So it would just be 1. And that is pretty much it. Number 16. This one caused a lot of confusion in every other class period. And like I mentioned when we went over the homework, there are so many different ways you can do these problems depending on how you think about it and how your brain is like processing the information. So again, the way I did it might be completely different from how you did it. I'm going to try to give you at least like 2 or 3 different ways that you could have thought about this question. And then from there, again, it could be that you thought of a different way as well. So what I did is for this movie theater question, I knew that there were 1, 2, 3, 4, 5, 6, 7. And I actually thought about all 5 people that we went with. And I gave myself a seat. I gave the friend I wanted to a seat. And then I thought about the remaining people that I have. So that's how I thought of it. And again, you could have just thought of every single seat as just being any seat possible. And we'll talk about that later. So once I fixed me and my friend in 2 seats, then I said that there are 3 remaining friends, the others, and I said that I'm able to arrange them in any kind of order. So it's the permutation of 3, 3, which means that there are 6 different ways that I'm able to arrange these people. But since technically I have 1, 2, so what I did here was I noticed that it doesn't really, or I'm not done with this problem because I didn't take into account the remaining seats. I could have me, my friend, person, or an empty seat, and then 1, 2, 3, and then another empty seat. So I had to take into account the 2 remaining seats that I have. So then from there, what I did was I multiplied it by the permutation of 5, 3. I acted as if this was like 1, 2, 3, 4, 5 remaining seats, multiplied it by the 6 different arrangements that I have. And lastly, because I'm just focused on this one row, I multiplied it by 2 to have the other row as well. And then the correct answer would be 720 out of 2,520, which reduces as a fraction to 2/7 or 0.2857. This was the least preferred method from every class, and it was the most confusing for everyone. So I do want to go over it in a couple of different ways as well, in methods that were shared from other students that I have written down here. So another way that someone thought about it was that, let's see, there's the friend and you, and then there are a remaining 1, 2, 3, 4, 5 seats. So what this person did was assumed that the friend and you were going to obviously be adjacent seats next to one another and moved the friend and you around. So there's 1, 2, 3, 4, 5, 6 different ways that you and your friend can be right next to each other with the 7 seats, which makes sense because if you have 7 seats and you want 2 people to be adjacent to one another, you would have 1 less possibility. So it would be 6 different ways that you could have you and your friend move within the 7 seats that you guys have here. So that would be 6. And then the denominator would simply just be the permutation of 7, 7. Of these 7 different seats that you have, how many different ways can you just have a different arrangement of all 7? And again, that would just be thinking of you, your friend, an empty seat, another empty seat, and then friend 1, friend 2, friend 3. And then lastly, you would multiply the numerator by everyone else. So how many different ways can you arrange your remaining friends based off of the fact that you and your friend are already sitting next to each other? So that would be the permutation of 6, 3, which is equal to 120. Then lastly, you would multiply it by 2 because I have your friend and you fixed in these specific spots, but you could also move you and your friend around. So if you think of all the different ways that you could be you, then friend, then it would be times 2. And the resulting answer would still be the same. You end up getting 2/7. Yes. Assuming that you and your friend are sitting next to each other, how many ways can you arrange the remaining people that you have? I'm assuming that my friend and me are going to be seated next to each other for all these different arrangements. So then I have 1, 2, 3, 4, 5, 6 possible ways, or 6 possible, like, I guess, seats. And then the 3 represents the remaining 3 people. How many different ways can I arrange the 3 people? So then that takes into account all the other blanks here. 1, 2, 3, 4, 5, 6. Again, another way you could have done this is not even think about the other people at all. So then what some people did was they just did it as a combination, which I didn't think would actually work. But then they said, no, it should work because, and again, this is where like you can think of this in a completely different way than I would have ever thought of it. 1, 2, 3, 4, 5, 6, 7. They said that the denominator would be the combination of 7, 2. And the reason for that is because they're saying, well, of the 7 different seats that you have, how many different ways can you just select any 2 of them? So they are completely ignoring the fact that you have 3 friends that are remaining, which I guess in this instance would actually work because the 3 remaining friends and the 2 empty seats still need to be filled in some way. So then they just completely ignore the other people and just want to know how many different ways can you select 2 seats that are going to be next to each other. It's these 2 seats. And again, if you're thinking of adjacent seats, then I already mentioned that the adjacent seats would be 1 less than the total number of seats, which is why it ended up being 6. I could have this seat 1, 2, 3, 4, 5, 6 different ways that you can select 2 seats that are right next to each other. And you would not have to multiply this by 2 because in this case, whether it was you and your friend or your friend and you, it wouldn't matter since we're not even worrying about the arrangement anymore, since we're not even thinking of this as in terms of the people. Again, I can go over probably 4 different ways that my students in other classes have thought about this problem. Another common one was 2 times 6 divided by the permutation of 7, 2, where we have, I'll just do this on another slide, 2, 6 permutation of 7, 2. This student said 1, 2, 3, 4, 5, 6, 7. Friend and you. And again, the 6 represents how many adjacent seats you could have, friend, you, etc. And went all the way down, said that there was 1, 2, 3, 4, 5, 6 different ways that you and your friend can be seated, times a 2 for the flip again, where it's your friend or you and then your friend. So that's the times 2 portion. And the denominator was a permutation of the 7 seats that you have. How many different ways can you arrange just 2 of them? And then still ended up getting the same answer. So I do want to emphasize again that the way that you think about these probability problems can be completely different than how I would have started it. And that's just fine. So that is also why I just kind of put the final answer there, because I don't want you to try to memorize some kind of rule in which to follow and try to always do it the way that I'm doing it. I also want to mention that we are doing such a brief little overview on